Welcome to this explainer. Today, we are looking at what is honestly one of the most massive paradigm shifts in the entire history of software development. Think about it. For decades, our job as developers was to write explicit, hard-coded rules for computers to follow. We built the exact logic paths, step by step. But today, we're moving into an era where we rigorously guide an AI to do that heavy lifting for us. We're opening up the developer's AI toolbox to focus specifically on prompt engineering techniques. Now, just think back to a very short time ago when AI felt like, a neat toy, a casual chatbot you might ask to write a funny poem or summarize an article. Well, now it is an absolutely critical infrastructure component. This explainer is where we stop treating AI like a magic 8-ball and start treating it like a predictable, production-grade component in our code bases.
Okay, let's dive into this. Here is our roadmap for today. 1. The prompt engineering shift. 2. Mastering instruction prompting. 3. Advanced reasoning strategies. 4. The power of chaining. 5. Essential best practices. And finally, 6. Testing and quality metrics. Let's get right into it.
Section 1. The prompt engineering shift. Look, when you first plug a large language model into an application, it is incredibly easy to get caught off guard. You connect to an API, send a basic prompt, and you get a decent answer. Pretty magical, right? But then you tweak a single word in your request, and suddenly the model responds like an entirely different system, outputting completely unpredictable formats. So you might be wondering, why go through the trouble? Let's look at why it's absolutely worth it by thinking about a classic developer nightmare. How do you extract messy, unstructured data without brittle, regular expressions? If you've ever tried to write a regex pattern to parse 1,000 inconsistently formatted emails just to grab names and phone numbers, you know the deep existential dread I'm talking about. You spend hours writing a monolithic block of cryptic symbols to handle all these crazy edge cases, only for a new, slightly different email signature format to completely break your entire parser in production. It is frustrating, it's time-consuming, and it's just highly prone to failure.
And this brings us to a fundamental truth of modern development. LLMs must be rigorously engineered, not just casually conversed with. By treating the prompt as actual code, you gain absolute control over the output. You see, you aren't just asking for a favor anymore. You are literally configuring a system. Prompt engineering is the primary lever we have to dictate tone, enforce strict JSON formatting, and establish real system constraints. When you explicitly define those boundaries and expected behaviors in your prompt, it transforms the AI. It takes it from a wild card that might hallucinate formatting into a highly reliable teammate that processes unstructured text better than any regular expression ever could.
Section 2. Mastering instruction prompting. Instruction prompting is really the foundational tool where large language models absolutely excel right out of the box, with literally zero fine-tuning required. With just concise, positive commands, you can drive incredibly powerful tasks. Let's talk about data extraction first. Instead of that messy regex we just talked about, your prompts can simply be extract the company names and financial figures from the following text and output them as a strict JSON array. And boom, the model just does it. Or consider security compliance, specifically personally identifiable information, or PII removal. You can pass user transcripts into a model with the strict instruction. Replace all names, addresses, and phone numbers with the tag redacted. In milliseconds, you have clean, safe data. You can even generate realistic synthetic data to populate a testing database just by describing the schema you want. You don't need giant labeled datasets or complex hand-built parsers anymore. The whole shebang is handled. You just need a well-crafted instruction prompt.
Section 3. Advanced reasoning strategies.
So, what happens when you need the model to handle intricate, multi-step tasks? A basic instruction prompt just won't cut it there. That's where chain of thought, or CoT, comes into play. Chain of thought is a prompting technique that explicitly asks the model to think step by step. The implementation can actually be remarkably simple. Often it's just appending the exact phrase, "let's think step by step," to the end of your prompt. Why does this matter so much? Well, imagine giving an LLM a complex logic puzzle or a really tricky math word problem. If you ask for the final answer immediately, it often just guesses wrong. But by forcing the model to surface its intermediate rationales and basically write out its scratchpad of logic before giving that final answer, you significantly improve its accuracy. Now the trade-off is that it costs more tokens because the output generation is physically longer. But in return, you gain a highly transparent audit trail of exactly how the model reached its conclusion.
On the flip side of that coin, we have chain of density, or CoD. This is the leaner, meaner alternative to chain of thought. Instead of asking for a drawn-out, step-by-step explanation, chain of density instructs the model to keep its reasoning incredibly terse and compressed.
When you use this technique, you are asking the model to pack as many relevant entities and facts as possible into a very short, dense paragraph. It completely strips away the conversational fluff. This is absolutely perfect for production scenarios where speed, low latency, and cost optimization are your highest priorities. When you just need the dense facts and don't necessarily require a long, transparent explanation of how the model got there, chain of density is an incredibly efficient tool to reach for.
Now, what's really interesting about this slide is how it creates a fascinating dilemma for developers. We are constantly balancing performance against cost, right? Choosing between these strategies depends entirely on your specific use case. If you are building a financial compliance tool where a human auditor needs you to explain exactly why a specific transaction was flagged for review, chain of thought is your go-to. The transparent, step-by-step logic entirely justifies that higher token cost. But let's say you are building a real-time chat moderation filter in a multiplayer video game that needs to process thousands of user messages a second. You simply cannot afford that latency. In that case, chain of density is the exact right tool to quickly identify toxicity while keeping your latency and token spending strictly in check.
Section 4. The power of chaining.
Let's move to and see how this builds, because once you master individual prompts, it is time to orchestrate them. In traditional software engineering, we don't write one massive 1,000-line function to run our entire application, do we? No, we break it down into modular pieces. Prompt chaining applies that exact same engineering principle to large language models. We break monolithic, error-prone mega prompts into manageable sequential steps. Here is how it flows. First, you execute your initial prompt. For example, taking a customer support ticket and asking the model to output the user's core intent in strict JSON format. Second, your application code captures that intermediate JSON output. Third, you programmatically pass that specific intent variable as the input into your next prompt, perhaps a prompt designed to query a database for relevant help articles. Finally, you take those articles and feed them into a third prompt to generate the final response for the user. You are literally composing functions, routing natural language through intelligent nodes. It's brilliant.
And breaking things down like this unlocks massive, massive developer benefits. Because you aren't using an all-in-one mega prompt, you get really straightforward debugging. If a step fails, you know exactly which specific prompt broke in the chain. You also get component reuse. Your highly tuned extract email fields prompt can be used in both your customer support pipeline and your sales pipeline without changing a single word. Furthermore, chaining drastically lowers token load and prevents a major LLM vulnerability known as the lost in the middle effect. When you stuff too much context into one prompt, models actually tend to forget the information located in the middle of the text. By chaining, each prompt only sees the exact small slice of data it needs to do its specific job. Plus, and this is huge, you can insert standard code-based guardrails, like a simple JSON validation script, right between the LLM steps to prevent any hallucinations from cascading down the chain.
Section 5. Essential Best Practices.
So the crucial point is that building these systems is exciting, but maintaining them requires true engineering discipline. First off, always focus on the positive. Tell the model exactly what you want it to do, rather than giving it a massive list of what not to do. Models follow positive constraints much better. Second, collaborate. Use the LLM itself to help you brainstorm and refine your prompt structures. Ask it how it would prefer the prompt to be formatted. Third, and perhaps most importantly, treat your prompts like code. Version them in your Git repository. Why is this so vital? Because if OpenAI or Anthropic updates a foundational model under the hood, a prompt that worked beautifully yesterday might suddenly break today. You absolutely need that Git commit history to quickly roll back or track changes over time. Finally, experiment constantly. You must A/B test and benchmark your prompt variants, because failing to track performance can lead to silent quality drift in your application.
Section 6. Testing and Quality Metrics.
So, after all this, how do we definitively know if all this prompt engineering we've done is actually working? Relying on human vibes or manual review is a massive bottleneck in production. To avoid those manual bottlenecks, developers need to implement automated scoring metrics. Tools like Blue and Rouge are incredible for programmatically checking text similarity. Under the hood, these metrics analyze n-grams, which are basically chunks of words, to mathematically score how closely a model's generated summary matches an ideal human-written reference summary. You get a definitive numerical score on quality, not just a guess. For classification tasks, like our earlier example of sorting support tickets, you don't even need anything new. You can rely on standard data science metrics like accuracy and F1 scores. Integrating these mathematical metrics into your continuous integration pipeline ensures that a tiny tweak to a prompt doesn't accidentally degrade the quality of your entire system behind your back.
We have covered a lot of ground today, from moving past brittle regular expressions to mastering chain-of-thought reasoning, prompt orchestration, and automated mathematical testing. You now have a structured, rigorous toolkit for interacting with large language models. So I want to leave you with the final thought. How will you implement these engineering principles into your next AI feature? Don't just chat with your models anymore, engineer them. Thanks for joining me for this explainer, and I'll see you next time.